Hello, I'm Brent Ferris from the Bearded Man Studios, and what I want to go over is how you can actually get variable or floating inputs or external inputs across the network with the authoritative model. In the previous videos, we saw that you could pass over key presses and mouse clicks, and now I want to show you how you can get floating point values or any other input type, whether it's based on gesture or cameras or anything, across the network with an authoritative model. So we're going to start off by writing two scripts. So over here, instead of the scripts of the authoritative and client prediction, I'm going to create one script called body, and I'm going to create a second script which I will call floats. So over here we have floats and we have body. So let's start off with floats. What we're going to do is we're going to be using beardedmanstudios.network. I'm going to reload. Okay, now I have my IntelliSense back on, and I'm going to make this a NetworkMonoBehavior. And what I'm going to do is I'm going to make two floats. So public float horizontal equals 0.0f and public float vertical equals 0.0f. What I'm going to do is I'm going to serialize these across the network. So netsync on both of these. And now we're going to make an update. So protected override void update. And what we're going to do is we're going to say if not is owner, return. I'll explain why in a moment. Horizontal equals input get axis horizontal. Vertical equals input get axis vertical. Okay, so I'll go more in depth in this in a moment, but basically this float script is not going to be authoritative. It's purely going to be a script that is only for replicating the user inputs, which in this case are floating point values. The other script, which is going to be the body, is going to be in control of the position, rotation, and all the rest of the transformations, but that is going to be authoritative, and we'll see how they work together. So we're going to jump over to the body script, and we're going to do something similar. We're going to be using Bearded Man Studios network, and this is also going to be a networked monobehavior. Now we're going to make three floats. Public float speed, this is just how fast the cube's going to move. Public float horizontal horizontal equals 0. Public float vertical. Okay, and now we're going to make a reference to the floats class. So public floats, we'll just call this input controller. And then we're going to make a protected override void update. And in here we're going to say horizontal is equal to input controller dot horizontal times speed times time dot delta time. And vertical is equal to input controller dot vertical times speed times time dot delta time. And then finally transform dot position plus equals vector 3 horizontal vertical and 0. So I know these guys have rigid bodies, but I'm just going to shift their position based on what's passed over. So this is going to be a new vector 3. Okay, so we're going to attach both of these scripts to our cube, and I'll show you how we can set them up so that one's authoritative and the other is not. So first I'm going to go to the authoritative and client prediction. I'm going to go to prefabs and this forge cube. There's a previous input controller that we used for the keyboard inputs, but I'm going to remove that one. And what I'm going to do is I'm actually going to add the floats and the body script. So first I'm going to add the body script. Let me select the right thing. Body. Okay, so the body is authoritative. It does have client-side prediction. It does interpolate, and it does set its positions. Now I'm going to add the floats script, which remember is what we're using for the actual inputs of, let's say, a joystick or anything else that uses horizontal and vertical built-in Unity. And what we're going to do is we're going to turn off interpolation because we don't need to interpolate the inputs. We just need to get the latest. We're going to turn off all the positioning stuff so that position is not synchronized on this script. And we're going to turn off teleport to initial position because that's taken care of on the other script. We don't need to do anything more to this script, but what we do need to do is drag floats into our input controller here so that the body has a reference to this as the input controller. So a quick overview, and we'll start with floats, and let's look at the game code. So floats has two variables that it's synchronizing across the network. So this is being replicated from the client. And if it's not the owner, then we don't do any of this, so we just return. So this is getting the actual inputs from horizontal and vertical, which is bound to the keyboard, but it's also bound to joysticks. And what's happening is that we have turned off all of the replication on this script so that nothing's being replicated except for the floats that we've specified with NetSync. The next thing is the body. The body has almost everything turned on. It has authority turned on, it has client-side prediction turned on, it has interpolation turned on, it has position and rotation synchronization turned on, and it has teleport to initial positions turned on. Lastly, it has the input controller, which has those floats put into its input controller field. Now, being that this is server's authority, all of these things are going to be happening on the server and not on the client. The client is going to be predicting them. So if we looked at the body script, we have a horizontal and vertical, which we are actually just assigning to what the input controller values are. Of course, we could have just passed them in directly. And then we're just multiplying by some arbitrary speed and delta time, so it's normalized across CPUs. And then we have the input controller, which is a reference to the script that the client is going to be replicating the variables across for horizontal and vertical, the floating point values. And we're accessing those values here, horizontal and vertical. Since they are replicated from the client to the server, then on the server side of the code, whenever it hits this code, it's actually going to be grabbing those values from the client and performing on them. And with client-side prediction, the client will also predict with this code as well. So nothing left to do but to build it and test it out. So I'm going to go to server or authoritative and client prediction. I'm going to copy the scene name, and I'm going to go to the canvas and make sure that's the scene that loads. I'm going to build it, and we'll continue. Okay, I have it built, so I'm going to start up the server here, and I'm going to start up the client. Join server with IP. We see it's being replicated. Now I'm going to use the arrow keys to move it, and it's actually moving with the horizontal and vertical inputs, and it is also replicating everything here. Let me select this guy, and we can go down here. This is another reason I made it public. And we could see that the inputs from the client are being replicated across the server. This over here is the server, and I'm just viewing the cube. So its values are being replicated. So that's it. So that's how I can get floating point values across the network. Now, the magic behind this is that in Forge networking, we have created everything so modular that we've designed it or tried our best to design it as modular as possible so that we can mix and match things to make it extremely powerful. Since we can mix non-authoritative code with authoritative code, we can get some dynamic values very easily across the network and get it to still be secure. So though the inputs are being passed from the client to the server, the client is not really controlling the position. The server is controlling it because the script responsible for serializing the positions and rotations is authoritative. So if you have any questions, please let me know. We'd be happy to help. And thanks for watching and participating in Forge Networking.